Well, hello students of Las Montañas Science classes. This is a video to help you understand what front loading is and also how to take notes on a video because that's what 90% of your front loading will be for my class. So the first thing we have to do is look at what is front loading to begin with. So front loading is basically homework, but you do it before class. So we don't like to call it homework because you don't take things home and practice them. What you're going to do is get acquainted with something, or you're going to do work before class begins. So basically every day in my class, you will have front loading. So you need to get online and go to the syllabus and make sure that you click on your syllabus and then go to the day. And you can look it up by the date or by the day of the term. Because remember, there's only 18 days in a term. So on day 1, which in this term right now was January 7th, there was a front loading assignment and you have to finish that before the following school day, which would be the 8th, which is also day 2. So make sure you check it every day. A couple of things I really want you to know about it. I don't want it to take you forever. So my front loading should only take about 15 minutes or less. Definitely not a half hour, definitely not an hour. I just want you to be spending maybe an hour per week outside of class on stuff for this class, not more than that. Of course, if you're absent, then you have makeup work and then you're going to be taking a lot longer outside of class. But for regular front loading with good attendance, I want you to keep it simple. Why do we do front loading? At first I was like, are kids even going to do this? But it really is a good idea. It helps you build background knowledge so that the first time you hear of something, it's not during class, because a lot of things in science are really complicated and you really never have heard of them before. So it is a good idea to watch these videos or read these little links that I give you, because it's going to help you understand something about what you're supposed to be learning before you have to start learning it. If you have background knowledge on a topic, then it engages it and it brings it back up so that you can think about it before class, and that way you're ready in class. So you need to do your front loading. I will keep track of it and it's available every day on your syllabus. The last thing I want to do in this video is show you how to take notes on a video. So how much are you supposed to write? Well, I don't know exactly. I mean, you need to write enough for you to be able to answer the question, what was the video about? So you don't really have to tell me all the details. The details are like bonuses. You want to remember some details, but what I really want you to focus on is getting the main idea. What is the big picture? So focus not on a whole bunch of little details. Focus on being able to answer the question like, what did you learn during this video? Or what was the video about? Because that's going to help you in class a lot more than just writing down a bunch of details and writing pages and pages of stuff. I have had some students write pages and pages of stuff. If you really want to do that, you can, but that's not a requirement. So I have a little video for us to look at right now, and it's called The Science of Skin Color. So the first thing that I would always do on my piece of paper if I'm going to be working on taking a front loading note is I would write 2 pieces of information. I'm going to write the day number. So this is maybe my front loading for day number 1, and also the date that that front loading was assigned. So today is the 8th of January, but this front loading was assigned for the 7th. So that's what I'm going to put on my paper. In fact, I think I can make my screen a little bigger and show you. Oh yeah, okay, cool. So now you'll be able to see it. So the other thing I would do is put the title of the video. So this one is called The Science of Skin Color. And it is a TED Ed video. So it's by somebody, like there's an author on here, Angela Coney Flynn, but I'm just going to put TED Ed because if I was ever going to look it up again, I would look it up as TED Ed. But you can see right here how I have just written, whoop, let me move this. Okay, so I've just written the day number and the date and the title. And this is on the back of a piece of paper. So any piece of paper that you have that you can put into your tab for the class period that you have, my class, that's where you want to write this stuff. Don't do it in a notebook because then you'd have to tear it out and put it back into your portfolio. So just work on getting it on a loose leaf of paper. And then I can screen, bye. Okay, so now I'm going to play the video and I will pause it when I would write something down and tell you why I would write it down. Here we go.
When ultraviolet sunlight hits our skin, it affects each of us a little differently. Depending on skin color, it'll take only minutes of exposure to turn one person beetroot pink, while another requires hours to experience the slightest change. So what's to account for that difference, and how did our skin come to take on so many different hues to begin with? Whatever the color, our skin...
Okay, so here for the notes, I wrote down this right here. I said, UV light causes the sunburns or tans. I didn't write down that different people have different skin tones and it takes them different amounts of time to get sunburned, because I just know that. So I don't need to write that down, because that's something I've experienced in everyday life. And so it's not something that's new or specifically related to like a science test question that I wouldn't get right. So I'm going to go ahead and shrink this back down and keep going.
Tells an epic tale of human intrepidness and adaptability, revealing its variance to be a function of biology. It all centers around melanin, the pigment that gives skin and hair its color. This ingredient comes from skin cells called melanocytes and takes two basic forms. There's eumelanin, which gives rise to...
So right now I'm pausing because I'm writing down the definition of melanin, and since there's two types and she's saying them pretty fast, I'm going to pause it really quick and write down the two ways of spelling it. So eumelanin, and that one is brown skin or brown color. I'll just keep going now to see what I really want to write.
To a range of brown skin tones as well as black, brown, and blonde hair. And pheomelanin, which causes the reddish browns of freckles and red hair.
Okay, so here's another one where I'm going to pause it just so I can get the vocabulary word. So this is a detail, but I want to know it. Like, I want to be able to talk about it in the future. And so this one is the one that causes freckles and red hair. Please excuse Mr. Arneson back here. He's just getting his coffee. Okay, let's keep going. Oh no, I started it over again. Here, I'll get us back. I don't want to watch that again. There we go. Play.
Red hair. But humans weren't always like this. Our varying skin tones were formed by an evolutionary process driven by the sun. It began some 50,000 years ago when our ancestors migrated north from Africa and into Europe and Asia. These ancient humans lived between the equator and the Tropic of Capricorn, a region saturated by the sun's UV-carrying rays. When skin is exposed to UV for long periods of time, the UV light damages the DNA within our cells, and skin starts to burn. If that damage is severe enough, the cell's mutations can lead to melanoma, a deadly cancer that forms in the skin's melanocytes. Sunscreen as we know it today didn't exist 50,000 years ago. So how did our ancestors cope with this onslaught of UV? The key to survival lay in their own personal sunscreen, manufactured beneath the skin, melanin. The type and amount of melanin in your skin determines whether you'll be more or less protected from the sun. This comes down to the skin's response as sunlight strikes it. When it's exposed to UV light, that triggers special light-sensitive receptors called rhodopsin, which stimulate the production of melanin to shield cells from damage. For light-skinned people, that extra melanin darkens their skin and produces a tan. Over the course of generations, humans living at the sun-saturated latitudes in Africa adapted to have a higher melanin production threshold and more eumelanin, giving skin a darker tone. This built-in sun shield helped protect them from melanoma, likely making them evolutionarily fitter and capable of passing this useful trait on to new generations. But soon, some of our sun-adapted ancestors migrated northward out of the tropical zone, spreading far and wide across the Earth. The further north they traveled, the less direct sunshine they saw. This was a problem, because although UV light can damage skin, it also has an important parallel benefit. UV helps our bodies produce vitamin D, an ingredient that strengthens bones and lets us absorb vital minerals like calcium, iron, magnesium, phosphate, and zinc. Without it, humans experience serious fatigue and weakened bones that can cause a condition known as rickets. For humans whose dark skin effectively blocked whatever sunlight there was, vitamin D deficiency would have posed a serious threat in the north. But some of them happened to produce less melanin. They were exposed to small enough amounts of light that melanoma was less likely, and their lighter skin better absorbed the UV light. So they benefited from vitamin D, developed strong bones, and survived well enough to produce healthy offspring.
All right, so I've actually written quite a bit right here. I added something. So right here where I had put melanin, which is a pigment, I also put a little star that says natural sunscreen because that's basically what they just said it is. So like if you have darker skin, then you have a natural sunscreen, and when you're getting a tan, that's because your skin is trying to keep from getting sunburned. So I don't get a tan, I just get a sunburn because I'm really white, but I'll tell you why in a second. So the two types of melanin, I didn't add anything there, but instead of just writing down that if you live closer to the tropical part, the equator, then you're going to have darker skin, and the poles you're going to have lighter skin, I drew a little diagram of the Earth. Oops, it's way over here. This is backwards. So it's way over here because I drew a picture of the Earth, and then I have the poles. You're going to have light skin and vitamins that you have to absorb, and that's why your skin gets lighter. And then at the tropics, you're going to have darker skin, and you need natural sunscreen, so that's why your skin is darker. I'm going to write another note that says the original skin color is black, because no matter where you live on the planet, your ancestors lived near the poles, and that means that you are, no matter what color your skin tone is now, you are descended from black people. So if you're still black, then, you know, you're descended from black people. But even I, who am really super white, am descended from black people. I think that's really important because a lot of times when we talk about like racism in culture and marginalization, people have made up race basically. So if we look at a scientific level, when you're a biologist or a scientist, race isn't even a thing. Race is a social construct. That means people made it to marginalize groups. But if we're looking at a science level, our cells are basically the same. That DNA is basically the same. It's just your response to the sun, your ancestors' response to the sun. More of them were able to reproduce if they lived near the equator, if they had darker skin because they were healthier. But then near the poles, if they had lighter skin, they were healthier. And that's just because your body needs vitamin D and natural sunscreen. So that's kind of cool. I mean, I like that. So I'm going to write that down also.
Over many generations of selection, skin color in those regions gradually lightened. As a result of our ancestors' adaptability, today the planet is full of people with a vast palette of skin colors. Typically, darker eumelanin-rich skin in the hot, sunny band around the equator, and increasingly lighter pheomelanin-rich skin shades fanning outwards as the sunshine dwindles. Therefore, skin color is little more than an adaptive trait for living on a rock that orbits the sun. It may absorb light, but it certainly does not reflect character.
Okay, one last thing before I wrap this up. If you asked me what this video is about, I would say it's about how human skin tone evolved as a response to how much sun your ancestors got. Now, I will note, so I live in Las Cruces. That's at about 32 degrees north of the equator, so just a little bit above the tropics. And the people who have lived here ancestrally, so the people who have lived here for a long time, are Native Americans. Well, I guess we would say Native North and South Americans because that's where we live. And their skin tone is typically a lot darker than mine. So why is mine light? Well, because my ancestors moved here. I'm actually a quarter Finn, and the Finland is really up by the poles. There are days in Finland where it's just dark all day because you just don't get any sun. So my ancestors were living in that really light place, and then I moved here. But my skin can't evolve itself because you get different evolutionary things within groups. That's really important because you can't personally choose to evolve. You evolve as a species. So there are different, basically, groups of humans according to their distance from the equator that have had different skin tones, but it's just a response to how much sun there was. So it's a cool thing, I think. The last thing that I did on here was I put on my little diagram of the Earth here, I decided to put the pH and the EU, those stand for the eumelanin and the phenylalanine, so that I know like when you're closer to the poles, you have more of the phenylalanine, and when you're closer to the equator, you have more of the eumelanin. So that is basically all I would write for this video. It's not very much. This was a 5-minute video, so if you were looking at something that was twice as long, you might need to write, you know, approximately twice more. But I mean, a good quarter of what I wrote, almost half, is just a diagram. So really, how much do you need to write? As much as you need to write to be able to answer what the video was about. All right, thank you guys. You can email me if you have any questions or additional concerns, but I hope this is helpful to you.